Okay, so we're going to model the second part of the assembly now to get the full Stirling engine, and that's going to be the chamber. And the chamber is this part where my mouse is showing. Sorry about the pop-up, it's just how I like to have my browser. So we're going to be making this center part out of acrylic or some kind of plastic that we can. So let's go ahead and get into Inventor and get started on that. So here is the one that I already made. The ghost of it is because of the material that I applied to it. So let's change that to something that you can see a little bit better. Carbon steel, why not? It's pretty solid. Okay, so here's the part. Start out with a sketch with the diameter of the actual chamber to the outside, and then an inner sketch for the wall thickness. Moving on, we then extruded that out a certain distance, 25 millimeters, which is the height of the part. Did a second sketch, which was for the holes on the outside, so those are external. Extruded those out and finished with a hole command and then a circular pattern net. So let's go ahead and start making it ourselves. Okay, so we'll go ahead and start a new file, standard millimeter.ipt. Select OK. We're going to get into here, do a circle from the origin, drag it out, dimension this to 97.2 millimeters. That's what I found it to be, with a little bit of subtraction and whatnot when measuring a thing. So we have that, and then we have a second circle to the inside, and then we're going to dimension that to a wall thickness of 2 millimeters. Okay, with that, we can now finish the sketch. Go to Extrude in the Create toolbar of the Model toolbar. Select the section in between the two lines. It's very important you select that. For the distance, it's going to be 25 millimeters straight on up. And we will select OK at this point. From this, select the front on the view cube, or orient yourself however which way you please so that we're facing like we are right now, as if we were in the sketch environment. And we'll start with a Create 2D sketch on the outer ring of this, because that'll put you in the correct plane. I'm going to sketch a circle, put it out here in limbo so that you're not constrained in any which way. Dimension this to 5 millimeters. And then constrain it with a tangent constraint. This will put this circle tangent to this circle, so that these two faces are just kissing each other. We'll go ahead and do a circular pattern of this because we have 8 holes. So you'll select your geometry as the circle that we sketched, and then your axis is the axis of which this is going to rotate about. So we can select the outer ring of your sketch, and it'll infer where you want to go. And we want 8 of these. We want to do a full 360 degrees. So select OK, and then we can finish the sketch. With the sketch finished, we can extrude these out. So you're going to have to go through and click each of the little 8 guys, which doesn't take too long. I'm going to extrude them 25 millimeters. Right now we want to rotate the part to see if we're going in the right direction, and we're obviously not. So we can flip that with this. And then it infer that I want to do a cut because of that tangent relation. It thinks I'm trying to cut out a very small piece out of the side of it, infinitesimally small. But what we want to do is a join. See how it automatically decided to give me that preview back. So with that, I'm going to say OK. Let's orient this around a little bit. You can see we're getting pretty close to where I was a minute ago with this finished part. The only thing that we need now is the hole. So what we're going to do is, let's see here, whoops, I want this face, and then I want to orient myself just because I like to see the words facing up. No other reason right now. Each of these is going to have their own hole, so we'll select the center of them, but it's not truly the center. We have to select reference. So this is placing the hole. We select the face that we want to put it on, which is this top plane of the long skinny cylinder, and then we'll select a reference so that it knows where to place itself on that. And we'll select the outer ring, and that'll make it concentric with that outer ring. With that complete, we're going to select this second option for a clearance hole, and we're going to use an ISO countersunk flat head screw ISO 2000. Second option, and second option here, the ISO 2010 version, a raised head screw. We're going to give it actually an M2.5. In the last video where we made the two flat bases, the tapered ends of this piece, we use M3. That's because that hole had to be, it's going to be a metal plate, and that's going to have the screw go through freely. This part is where the seal matters because this is the actual chamber. So any leaks here is bad news. So when we put our screws in the real world, it has to be an interference fit, so we're actually screwing through the material. So, and we'll also make this a close. So that's going to be 2.7 millimeter diameter there. We're going to go ahead and hit apply, cancel out of that. And you see we got it on just one of the holes here, so we're going to have to do a circular pattern, which is up here in the pattern part of the model toolbar. Select your feature, which you might have to rotate the screen a little bit to grab onto it there. You see how it highlights along the entire axis there. Zoom back out, select your rotation axis, which mine is not showing. Let's see here. Let's cancel out of that, bring it back into the circular pattern. Go back in, grab the hole. There we go. And then we'll do 8 of those, and that'll line it up perfectly. We had 8 at 360 degrees, now we have 8 at 360 degrees again. So there is our part with each hole made to the correct dimensions. Just go back through that. We start with extrusion of a circle, 2 circles rather, so that we can get a thin type body with no bottom, no top, which is what we wanted. Dimension 97.2 with a 2 millimeter separation. Extruded it out 25 millimeters right there. Followed by that, we did a second extrusion of these side tubes, dimensioned them to 5 millimeters wide, and made them tangent to this outer ring that I'm highlighting in red right now. Extrude that up 25 millimeters. Made a hole in one of them that was dimensioned as the hole should be. Doing ISO raised head with, let's see here, I can't remember everything off the top of my head, M2.5 and a close fit. Then we circular pattern that all the way around. I hope this helps, and I hope you continue along with the project with me.